Hello, everyone, and Happy New Year. Hope everyone had great holidays and some time to recharge and be ready for an exciting new year. I wanted to update or put an update out there on the Raspberry Pi 5 project that I've been working on. I've been working on building an access point based on the Raspberry Pi 5, and my choice of OS was OpenWrt. The AB was basically a Raspberry Pi 5 with a MediaTek 7915 as a Wi-Fi chipset and OpenWrt as the operating system. So far, the AP has been doing excellent on performance metrics. I've tested the AP for the last 2 weeks on the RF level, throughput, latency, and other AP metrics. But the problem is that this is still a standalone access point. Every time I needed to make a change, I had to log into the console of the AP and make manual changes through the command line. So the next evolution in this project was to migrate the AP from a standalone mode into an enterprise stack. And for that, I chose the OpenWiFi stack. The obvious reason for my choice is OpenWiFi is an open stack. It's free and open for everyone, and you can go and clone the repo and play with it. And it's based on OpenWrt, so the migration was quite easy to go from a standalone OpenWrt to fully managed enterprise stack. As we can see here, I'm sharing my screen. We're looking at the OpenWiFi SDK controller. The controller now recognizes the Raspberry Pi model. It shows that is running a custom image based on the last GA, which is the 4.2.0. This image that I created over the last few weeks and have been tweaking. The AB has been up for the last 3 days now. It has a 4 gig of RAM, and it has an operational certificate that will expire in 5 years. We can also see the statistics here from the AP. This is the data. I've been testing this thoroughly, with 200 megabit per second continuous throughput for the last couple of days, and the AP has been stable with no issues, no reboots, and no freezes. We can see the packets. We can see the free memory. We can also see the history of the commands here, the AP. If we scroll back up, we can actually see the configuration, the JSON file we used to configure the AP. And we have a simple SSID now called Raspberry Pi 5-1. It's a WBA2 personal, and the password is 128. Not the most secure password, but this is just the lab. We also even see here the radio right now. There is a reporting bug right here. It's being reported as a 2G radio. It's actually right now, it's operating as a 5G radio. This is a dual band radio that can be either configured as a 2.4 or a 5 gigahertz radio. Let's go ahead and connect to the AP over the MTLS tunnel using RTTY functionality. I'm gonna log into the AP, OpenWiFi, and if we look at the IWinfo command, we can see here that the Raspberry Pi SSID name is Raspberry Pi 5-1. Now we'll try to make a small change through the controller. We'll go back to the controller, and we'll click on configure, and we'll pull up the current configuration, and we'll change the SSID name back to Raspberry Pi 5. Then we'll save. Clicking save will push the configuration down to the AP. If we scroll down here, we can actually see the history showing the configuration command that has been sent to the AP over the last 2 seconds. If we look at the details, we can actually see the 4-row data of what been sent down to the AP. We see here the name is Raspberry Pi 5 for the SSID instead of Raspberry Pi 5-1. So now let's go back to the RTTY, and again from the command line, let's double check this SSID name. We see how this SSID name has changed now to Raspberry Pi 5 according to the configuration that we push from the AP, from the controller to the AP. If we look at the services running, we can see that we have the uCentra client, which is the controller, which is the client responsible for communication with the controller. If we go back here, we actually see a client just popped in. This is one of my lab clients. We can see the AP reporting. This is the client, and basically it's a BE200, so you can see it's reporting as Intel. This is a conductive setup, so the RSSI is very high, like -34, and fire rates haven't updated yet since there are no traffic. But if we go, this is a client that MAC address ends with 3P. If we go back to the command line, and we can do station dump, we see our clients right here, clients connected, and we also see that like the fire rates hasn't updated yet since there are no traffic. But as I said earlier, there's a small bug here. This is reported as a 2G client instead of a 5G client, but client is connected and everything else is reporting. So now we have a full stack enterprise access point, and the next step is to continue testing the access point within the framework of the OpenWiFi controller and the OpenWiFi stack. Thank you.